My name is Wenming Yi. I'm a technical evangelist on the Windows Azure evangelism team. And today I have the honor to have Jay Haridas here.
Hi, it's an honor to be here and talk about Windows Azure Storage. I'm a principal dev lead in the Windows Azure Storage team, responsible for the front-end services for tables, blobs, and queues, and also the client libraries. So Windows Azure Storage is a cloud storage system, right? And with cloud getting all this attention nowadays, it's being used almost everywhere, right? You want your data to be accessible from anywhere at any time, and so cloud storage provides you a way to store your data. In addition, what it provides is also scalability. When you want to start storing like petabytes of data, you have to, there's a lot of planning that goes in, there's massive amount of planning that goes in, and cloud storage systems provide you these, and Windows Azure Storage does the same in terms of providing you a durable storage system, which is strongly consistent, and also provides geo-replication for your for the data. One of the favorite scenarios for me, coming from the Windows Live Storage where I used to work, is any service that you wanted to build used to take a lot of planning, right? And especially if you're talking about an ingestion engine to kind of consume the Twitter and Facebook feeds, and then create the indexes for a Bing search engine to kind of go and give the famous tweets and rather recent tweets and things like that. Right. We're talking about a large-scale system out here, and there is tremendous amount of planning that goes into the hardware, what kind of hardware you need and things like that, which would take basically a year to kind of get the service rolling, right? In the past. Ever since we had the Windows Azure system itself in place, there was this one dev who had this idea of consuming the Twitter and Facebook feeds, and what this one dev did in 2 months is have an ingestion engine that can be consumed by Bing to kind of give all these Twitter feeds and Facebook feeds almost at real time. This is the kind of scale that we're talking about, which is possible to build on top of Windows Azure Storage, which one may not have been able to build before a cloud storage system like this. Some of the challenges in a cloud storage system is basically how do you make your data durable, and agnostic to basically hardware failures and other failures that may happen in a distributed system itself. So that's one definite challenge that people need, like a cloud storage system team needs to think about. The other challenges that pose is we are a multi-tenancy system, right? So how do you provide isolation in a multi-tenancy system? And that's another challenge that we keep thinking about, and it's a pretty interesting problem that we have, and which we've solved. So these are some of the challenges that come into picture. With any distributed system where the failure points are a lot in terms of your network failures from your internet service provider, it's always nice to kind of have this reliable system out there which you can trust and build an application that can scale. So we need to think about those constructs that will allow you to build such a system, which can withstand such failures and still have a good reliability in terms of your application being distributed. So back in the 2011 August version, we released some real awesome features in storage, which are really useful for kind of analyzing and optimizing your applications. One is storage analytics, right? So storage analytics allows you to kind of optimize, learn more about how you're using storage, and then optimize it. A classic example is we had a customer who was using his queues, and he used to scale his application out to like 30 worker roles for his peak time traffic. And
that gets a little expensive.
It gets quite expensive, right, with the number of transactions. And then what he found is his peak time is about 3 hours in a day. And the rest of the time, it was basically 20 messages a second or something of that sort, which he was inserting. And he used the storage metrics to basically understand how his application is behaving. And then what he did was use the service management APIs to kind of downgrade the number of worker roles that he uses to just one worker role, with one thread kind of polling this Azure queue during off-peak hours, because 20 messages a second, that one worker role was sufficient. And then during peak hours, as the traffic built, he used to scale up using the service management APIs. So he was able to kind of get this optimization in cost, which was like a lot of cost savings for him, just by turning on analytics, storage analytics. We blogged about this. One of the things that we would like our customers to do is turn this on, because this allows you to analyze your data and how your usage is, and actually optimize on not only cost optimizations, but even performance optimizations.
I see.
In addition, we had some interesting features like queue update, message updates.
Yeah.
And what this allows you to do is basically save state of your message processing, so that you can build a kind of a pseudo workflow kind of an application or a processing worker role, where you go and process a message, update the state, so that the next worker role can take and do something else on that message. So you can have this, you can keep updating the messages and update the state.
Like a token.
It's like it's a token that you get. You can update it, but you keep saving these intermediate states. Where it's useful is, let's assume you're processing a huge, massive blob. When you're processing this blob, you might be processing regions of it, right?
Yeah.
And this processing itself takes quite a few hours. You don't want to start all over again whenever you have some kind of interruption in between your servers, right? So you can start saving state so you can continue your work and not have any wasteful work kind of go down the drain. So so update messages is definitely useful, and then we had some table features like upserts and things like that, which is very useful in terms of updating or inserting an entity without having to know whether it exists or not. And it, again, it has some cost benefits to it. When you talk about cloud storage, it is language agnostic, and we are showing our commitment towards cloud by releasing our Java storage client libraries. We will be releasing it very soon. And we will have blob and queues for the client library, which Joe out here, who's architected these libraries and implemented them, would talk about. And we will have the Java table library come out soon, sometime later next year. So we have all these. We are committed to delivering the Java client libraries. These are very easy to use. I spoke about cloud storage as this massive, scalable, durable, consistent thing, right? Anybody who hears it would think, oh, this needs a lot of code to handle. And Joe can show here that it just takes a few lines of code to upload a blob. Just a couple of lines and you are off and started. So with the storage client libraries, what we've done is made it really simple to use our storage system. And you build a scalable app very fast. And Joe can show some samples.
Hi, my name is Joe Giardino. And I'm going to show you some of the cool things coming up in the new Java client library to access storage. So some of the things that we did for Java is we took a lot of the feedback that we got from the .NET SDK, as well as look at some of the common practices in the Java community, etc., to just give what we consider a very kind of first-class experience, what it means to develop against Azure storage. So I'm going to show you just a quick sample here of just how easy it is to take advantage of the scalable, durable system that Jay just described. So the first thing I'm going to do is set up my cloud storage account using the credentials that I get through the portal when I first sign up. I'm going to create a blob client so I can interact with the blob service. Now, a common design pattern you're going to see throughout the library is that we use a local client-side object to interact with this object on the server. So I'm going to get a reference to a container object, and we'll call create if not exist. You can see the right in Fiddler. It says that container already exists. That's fine. Now I'm going to set the permissions of that container to public. And what this means is that any file that I upload to that container can be accessed through Internet Explorer or phone by anyone without having to know anything about my information or my account credentials. Set the permissions. All right, so now I actually want to upload an image to share. So I'm going to get a reference to a blob called desert.jpg, and it's going to live in the container that we just created. I'm going to call blob.upload. There's a lot of very advanced features that we put in the library that are very easy to use that should be helpful when creating your cloud application. So things like retry policy in the case of timeouts or connection interruption, or concurrency and parallelism for low latency uploads, as well as things like Content MD5 for transactional security. All right, so I'm going to get the URI to that blob. All right, I'm going to open up a browser window just to prove that that's public. And there's my image. So now I could post this URI online, could share it for anybody to download, and no one has to know anything about the storage system that's using to back this image, or my account information or credentials. So that's just one very simple, very quick sample of how you can use the library to talk to blob storage. There's a lot of really cool features that are built in the library. I encourage you to download the library, check out the Windows Azure Storage blog, as well as the forums. We've taken a lot of feedback from customers and people on the forums to make improvements in this library.
Just give me, one last thing that you would like to tell our audiences today.
Sure. I would definitely say that if you're working with Windows Azure Storage, definitely follow us on our blog, our team blog, which is Windows Azure Storage team blog. You should go there because we have some interesting articles coming up out there with respect to performance and with respect to new features that we'll be releasing and talking about more about Java libraries itself and what the thought processes, samples, and things like that. So you definitely should follow us on our Azure team blog.